I'm Raphaël Collet. I'm a developer and maintainer of the ORM and the server-side framework, which this test framework is part of. Remember that testing is a good thing in this meaning that if you have a good test suite, you can really consider it as an executable specification. Specification because it states that with some data the program should give some output and so on, and it's executable because you don't have to run it manually. You can make a whole test suite run automatically and check that it still satisfies its executable specification every time you touch the code. There's even some development technique that have been developed around test, and that's called test-driven development. Here I have some kind of a pseudocode that suggests how you proceed test-driven development, and the idea is every time you want to modify your code, you first write a test for stating what it should do, and the test should not pass with the existing code. You then modify your code to make the test pass. So the goal is to make the test pass, and then you can make several iterations where you refactor the code while keeping all tests passing. That's one way of developing. It's not exactly the way we develop at Odoo, but for some work, sometimes we use a method that's partly inspired by test-driven development. In the case of Odoo, we actually reuse and we actually inherit from the module unit tests in Python that provides a test case class, and we provide a few classes that inherit directly from those unit test classes. The Odoo test classes are actually designed and implemented to be executed on a test database, which is an actual Odoo database, and it proceeds with the management of opening a transaction and all that stuff. We provide two main classes. The main one is transaction case on the left-hand side, and the save point case here on the right-hand side can be seen as a kind of an optimization for some special case. The base is the transaction case. Essentially, this suggests a full execution of the test suite of a given class. Every test method is run after the other and is surrounded by a setup and teardown. Essentially, the setup creates a situation where the test can be executed, the tests proceed, and teardown essentially cleans up what the setup has done, or what the test method itself has done, to somehow put the system back in a normal state. In the transaction case, every method is executed in its own transaction from a database point of view. And we actually don't commit the transaction. So we execute some code within a transaction, and at the end, we simply close the cursor, and this just throws away the transaction without committing it. This is how tests are actually don't damage somehow the database. There are cases where actually the setup actually makes the setup sometimes is more costly than the test method itself. For instance, in stock modules, the developers have designed a setup where it's a kind of a controlled environment for running the stock methods, the stock functionalities. And the whole setup means they're creating a company they're creating stock locations, they're creating stock rules, and so on. They're even creating products that follow some rules, some stock specifications, some stock constraints, and so on. And the setup actually creates all this setup. We run the method, and then we throw everything away. If you want to somehow factor out this setup, you can use the save point case instead. The idea, instead of putting the whole setup in the setup method, you use the setup class method. It's executed once per class and not once per method. The setup class, the idea of the save point case is that the whole execution of the test is done in a single transaction. And for the test method, we make something like a sub-transaction by using save points. And therefore, the advantage, if you have a huge setup to make before making your test method, you do it in the setup classes, and then you run every test method, and thanks to the save point, you can somehow roll back every side effect of the test method. And go back to where the setup was ready. This is one way of, for instance, if you have performance issues for test, you can make them faster by somehow factoring out some setup for many test methods. We, we also have HTTP case and HTTP save point case. Essentially, those are tests where some HTTP processing is involved. And essentially, the HTTP case, once it's run, it actually launches and opens the HTTP server on the database. So the server is actually running, and it also spawns a browser, an actual browser that is connected to the test process. The browser allows to open any URL, that is to connect to the HTTP server, or even to run some JavaScript to perform something in the client, the Odoo client. It allows to test the web client, the web user client, or the website component, for instance. So this HTTP case essentially allows to drive a test from the browser instead of from the Python code itself. So you initiate something from the browser, go through the HTTP layer, the server processes the request and goes back, and then you can get the result of what the browser receives and updates and so on and so on. This is to drive a test from the browser. We use it for some testing, some tours, some functional flows through applications. The test instances, that is, the test objects that are instances of those classes, those test classes, they all have these attributes available on them. That is, the registry that contains the model and their classes, the cursor, which is the current transaction on the database, the current user ID, and the current environment. The most important part is the environment. This is from the environment that you can access anything, and that you can actually instantiate any record set, anything, and access the ORM through the environment. I'm now going to talk about specific bits of implementation, either things that we provide or things that Python provides, for making your tests better. One of them, it's an Odoo specific thing. It's a server-side form, so-called server-side form, and it's actually an implementation in Python of the client-side form. So this is the Python implementation of a form, and you can, with that form, create or edit records just like you would on your computer, on your browser. The server-side form, so it's actually a class called form, and this is how you use them. So when you instantiate this thing with a record, here we do it with an empty record set. If you do it with an empty record set, you're in the situation where you want to create a record. If you give an existing record, then you'll go for editing that record. So here we put an empty account move, we give it to the form, and what you get back is something that looks like a record, but is actually using all the functionalities of a form. That is, when you assign a field, all the read-only, the required attributes in the form are processed, and the on-change actions are performed as well. You can see here how you can assign a simple field. You see here, for instance, how you can add a new line inside a one-to-many field. And when you perform the method save, you invoke the method save on the form, you get back the actual record you've created thanks to that form. This is the other way to use the form view, is when you have an actual record, you can use the form on it, and you can use it as a context manager. Here you say, I'm gonna edit the record invoice through a pseudo record called move form. This is the form object, and there you can again assign fields. And for one-to-many fields, you can even edit a particular line of one-to-many fields. So here, for instance, this is editing the first line in those line IDs. You see? And this reproduces everything the form view would do. And by default, you can specify actually a specific form view to use, or by default, the form implementation will pick the default form view, the standard form view, let's say, depending on the context, as the client side would. This is useful for getting all the machinery that's involved with the form. This is another bit, and actually it's not specific to Odoo, but that's something you should think about doing. The method @cleanup allows to register a callback. And the way to use it, here I've actually copy-pasted the setup method of transaction case. It's the actual code of the method. There's no teardown in this case, and the reason is, every time we set up something, we register a cleanup to clean up what we've installed. So if you allocate something, you use @cleanup to register a callback to deallocate the resource you've been allocated. If you're patching something, essentially you have to register a cleanup for unpatching the thing. The advantage of @cleanup is that you can use it systematically to say, in my setup, I install something and I immediately add the cleanup to remove that thing, or to deallocate, or to remove that thing. And here, for instance, you allocate a cursor, and as a cleanup, you say, when this is being teared down, you have only to close the cursor, and that's how you deallocate. So when a test is cleared down, you'll first call the method reset on the environment, then close on the cursor, and then two methods to clear and reset the registry. And that's how you roll back everything. Another advice is to use the patch objects and methods from the unit test, especially unit test.mock library. This library allows to make mockups very easily and allows to patch also existing functions or classes to get a specific behavior. And this is also taken an example from an actual code. If you have things that are not really under control in a test, what's not really under control is the current day, for instance, the current date or the moment you're executing your test. This thing is not reproducible, of course, because it always changes. Every time you run the test, it changes. If you want to somehow stick your test in time, the simplest way is to patch one of the methods or some of the objects that provides the current date or current date time. And here, for instance, we've chosen some date, and we say we'll run the test as if we were the 4th of May 1979. This is a neat way of kind of sticking a test in time. And that's important for reproducibility. You can, of course, use other kind of mockups or patches. For instance, if you want to check the email delivery, but you don't want to actually deliver emails, you can actually patch the method that will perform the actual delivery to just record, yeah, I've been called once with these parameters, and so you don't make actual emails, but you know that you've been through the code up to the point where you wanted to send some email. This allows me to make some white box testing, for instance. The last thing I want to say is you have to maximize the coverage of your tests. This is something that we often we are a bit short of. The goal of maximizing coverage, of course, is to cover as many possibilities, as many cases as possible. To maximize this coverage, you have, of course, to cover every basic corner case. So every special case should be covered by one test. You also have to test with different users, because different users have different access rights. And this allows you to check what a user can do and a user cannot do. And this leads to the third point, test access errors. Make cases where the access right should allow you to do something, and cases where the access right should not allow you to do something. Sometimes we have kind of security gaps appearing because we forgot to test the cases where things can fail. And actually, access errors or security errors are one type of errors, but actually every kind of mistake can happen. Every kind of failure in the system should be tested. Like you want to process a delivery order, but you don't have enough products in stock. In such a case, you should not be able to deliver a product if it's not in stock. You need a test for that case to make sure this never happens. Et voilà, those were a bunch of guidelines for improving and hopefully getting better tests for your software. I thank you for following this talk, and I invite you to ask questions.
Hello, Raphael.
Hello.
I'm Christophe. Nice to meet you. Unfortunately, we have bad news.
Yeah, we actually the video started a bit late, and so we don't have enough time left for questions. So we won't answer questions right now. I invite you, You can keep asking questions on the chat. We'll answer them, and you can also come to the developers room. Those are the community rooms in the framework room where the team will be available, and I'll be there tomorrow, and you can ask questions live there. See you.
Thank you.